Okay, so now we're working on the problems from 11 to 20. This asks us to do a composite function, so we're putting the g function into the f function, and also the f function into the g function. Then we state the domains overall when we're done. And remember that we have our domain restrictions on rational functions, and then also radical functions, and combinations of radicals and rationals. So let's see here. We're going to go ahead and go through number 12 and number, let's see, and number 13. So we'll just do these two back to back. All right, so number 12. So for number 12, the f function is going to be equal to x squared minus 1, and then the g function is going to be equal to 2 minus x. So let's do f of g of x first, which is the same thing, by the way, as when it's asking for the questions, the same thing as that first thing, the f and then that circle and then the g. Because this notation is really just like, putting the f around the g, basically. Like, where you see the circle, just put parentheses and you've got an idea that, they're the same thing. So anyways, so what this is asking us to do is, put the g function in as the input, the x value, in other words, in the f function. So think about it like this, right? So if we start off with the f function and just leave that input value blank, then the f function is going to be blank squared minus 1. So what this is asking us to do is put the entire g function inside of there, g of x. So that means that g of x goes in here, into the blank. And remember that g of x is x minus 2. So this becomes x minus, I'm sorry, not x minus 2, 2 minus x. So this becomes 2 minus x squared minus 1. So now we just finish evaluating it. 2 minus x squared is 2 minus x times itself, 2 minus x, and then minus 1. So after foiling or distributing, 2 times 2 is 4. Negative x times 2 is negative 2x. 2 times negative x is negative 2x. Negative x times negative x is a positive x squared, and then minus 1. So now combine like terms, and let's rearrange it a little bit. Let's put the x squared first. There's no other terms to add on to it. Let's put the x's next. Negative 2 and negative 2 makes negative 4, so negative 4x. And then the constant value. So 4 and negative 1 add together to be a positive 3. So this is our composite function. F of g of x is equal to this. And then since it's quadratic and we're asked to find the domain, we know that it's going to be all real numbers, because the only domain restrictions that we'll have in class are, again, the rational functions, the radical functions, and then the combination of those two types of functions. Since the quadratic is neither of those, we don't have to worry about it. Okay, now let's do the other part of it, and that's going to be the g of x, f of x. Oops, g of f of x. There we go. So what this is asking us to do is plug the f function into the g function. So in other words, wherever we see the g function, so the input, let's leave it blank, is equal to 2 minus blank. So we're plugging in the entire f function into that blank. So that f function is x squared minus 1, so this becomes 2 minus x squared minus 1. So we distribute the negative in there, and we get 2 minus x squared plus 1. And then combining like terms, we end up with 1 plus 2 is 3, so 3 minus x squared is our composite function, f of x, g of f of x. Don't know why I keep messing that up. There we go. All right, so again, this is just a regular old quadratic. It's not a rational function, it's not a radical function, so the domain, again, is all real numbers. All right, so that's number 12. Now we're going to move on to number 13 on the next video.